the Honorable President of India, Honorable Minister of Agriculture, Mr. Sharad Pawar, Ms. Jenny Borlaug, daughter of Norman Borlaug, Dr. Ayyappan, Director General, Indian Council of Agricultural Research, Secretary of Agriculture, Mr. Bahaguna, Dr. Swapan Dada, Deputy Director General, Indian Council of Agricultural Research, and last but not least, the participants of the Borlaug Global Rust Initiative. Welcome to the 5th annual meeting of the BGRI. 47 countries are represented here tonight, and we have over 400 people registered for the conference. The BGRI community is growing in terms of the number of scientists, the diversity, the gender balance, the number of countries that are represented, and the number of farmers that we are reaching. The Borlaug Global Rust Initiative has the overarching objective to systematically reduce the world's vulnerability to stem, stripe, and leaf rust of wheat, facilitate the evolution of a sustainable international system to contain the threat of wheat rust, and enhance productivity required to withstand future global threats to wheat. The BGRI is a multilateral collaboration involving scientists, government bodies, national agricultural research centers, and private organizations across borders, contributing to global food security and the common good of increasing acreage of rust-resistant wheat. Because of the work done by so many in this room, smallholder farmers in Asia and Africa are obtaining new, durable, disease-resistant, and high-yielding varieties of wheat and experiencing many peripheral benefits. In this way, we continue the work of our champion, Norman E. Borlaug. This 2013 BGRI Technical Workshop commemorates the 50th anniversary of Norman E. Borlaug's first visit to India and is a harbinger of India's second Green Revolution for the 21st century. India has been an important partner in the BGRI since the beginning. We welcome the Indian Council of Agricultural Research and their proactive approach to the surveillance and breeding. Indian scientists have been extremely vigilant in sending promising wheat lines to rust screening facilities in Ethiopia and Kenya. And Indian wheat breeders are making good progress in developing durably resistant wheat varieties. In terms of achievements in the field, the BGRI has much to celebrate. Coverage of the world's wheat fields with rust-resistant varieties has increased significantly, especially in UG99 stricken areas of Eastern Africa, like Ethiopia, where projected coverage of disease-resistant wheat in the 2013-2014 season will be 50%. And right here in India, Indu Sharma, the director of the Directorate of Wheat Research, has told me that the number of hectares planted to the extremely rust-susceptible variety PBW343 has been reduced from 6 million hectares in 2005, when the BGRI was launched, to its present level of less than 2 million hectares. In terms of total acreage, that means in the last 5 years, the number of hectares of PBW343 has shrunk from more than half the acreage of wheat planted in India to a quarter of the area of wheat cultivated. And the replacement varieties are more resistant to yellow rust and stem rust, We also have good news to report in terms of research. A few recent achievements stand out. Jesse Poland at Kansas State University, along with colleagues from CIMMYT, Cornell, and collaborating national programs in South Asia, has received a $5 million grant from USAID for global hunger and food security research strategy, climate resilience, nutrition, and policy. Feed the Future Innovation Lab for climate resilient wheat. The goal of this project is to ensure that the yield and economic value of small farm wheat crops in South Asia increase rather than decreases through rapid development of superior climate resilient wheat varieties. Dr. Edward Okunoff of Kansas State, also in partnership with Les Sabo and Matt Rouse at USDA ARS in Minnesota, has received a $1.6 million grant from the Bill and Melinda Gates Foundation, who of course also supports our project, to work on fine-scale dissection of the host pathogen interaction landscape using genome-wide association scans of the host and pathogen genomes. The purpose is to comprehensively analyze the interaction between many hundreds of genes in a crop plant and infecting fungal disease, with the goal of generating new resources to protect farmers from crop losses. This week, the BGRI community also celebrates 2 companion papers in Science, examining genetic resistance to UG99 and SR33 and SR35 by 2 separate research teams of Evans Laguda at CSIRO in Australia and Jorge Dukowski at UC Davis in California. By cloning gene segments of an ancestral wheat species not often cultivated but closely related to bread and pasta wheat, they have succeeded in inserting the clone material into modern wheat varieties. The real breakthrough with this advance is the eventual ability to stack resistant genes in closely linked increments called cassettes using the modern tools of biotechnology. One word of caution that Dr. Borlaug would want me to include is that just as important as developing rust-resistant varieties of wheat is getting rid of the old rust-sucking varieties of wheat that pose a major threat to wheat production and food security in the path of stem rust and yellow rust. We're well on our way, but much work remains to be done. The BGRI was Dr. Borlaug's last great initiative. It's up to us to sustain it. What Dr. Borlaug would say to you if he were here tonight is that no matter who you are in the BGRI, your job is essential. Keep up the good work. That was his favorite expression. Thank you.